Right, shouldn't be anything to worry about, but we're just going to put a little bit of motion into this as well. So a particle is held at rest on a rough plane inclined at an angle alpha to the horizontal, where tan alpha is 0.75 and the coefficient of friction between the particle and the plane is 0.5. The particle is released from rest and slides down the plane. So in terms of a diagram, we're here, alpha, particle. So we've got the weight acting down. We've not been given the mass, so we've got mg acting down, normal reaction force, and friction that will oppose motion. But if the component of the weight acting parallel to the slope is more than the friction, then it will slide down the plane and accelerate. The thing you might want to think about doing with these questions is if you're given tan alpha, I know the other one I did, tan alpha was 3/4 as well, but do use Pythagoras for these. So you can just draw a little right angle triangle, don't worry about how you draw it. Alpha, tan alpha is opposite over adjacent, and then the square root of 3 squared plus 4 squared is equal to 5. So you can use Pythagoras to find that side. It may be that side will have a root wrapped around it or something like that. And then cos alpha is adjacent over hypotenuse, and sine alpha is opposite over hypotenuse. And sometimes I just do that straight away when I'm working through a question like this, because you know you're going to have to use them when you're resolving parallel perpendicular to the surface. So I quite like just having them on hand, or you could do that as you go through. Please don't go shift tan 3/4 alpha to get alpha and then do cos alpha, because you lose your exact form. So get out of the habit of doing that and instead actually keep cos alpha and sine alpha in exact form. I know mechanics isn't exact, but this is really how you want to be working with these. So the other thing, if it's moving down the plane, I want my positive direction to be in that direction. So keep your positive direction of motion. So resolving perpendicular to the plane, I know that R is equal to, so coming in here, that angle there is alpha, so R is equal to mg cos alpha. Cos alpha is equal to 4/5. So R is equal to 4/5 mg. We know the frictional force is equal to mu r. And so this F here is at a maximum, is equal to 0.5 times 4/5 mg. And so F is equal to 2/5 mg. And then resolving parallel to the plane. So it's sliding down the plane, we've got some motion, and so we want to use resultant force is equal to mass. So resultant force is equal to mass times acceleration. I'm getting more and more into this. I'm sure Paul does this in physics, but if you write in F max is mu r and the sum of F for your resultant force equals ma, otherwise you just end up with all these F's everywhere, and it just kind of isolates it out a little bit. So resultant force acting down the plane, I've got mg sine alpha acting in my positive direction. And then I want to take away F. I'll leave it like that for a minute. And then that is equal to the mass times the acceleration. So if I tidy that up a little bit, sine alpha is equal to 3/5. So 3/5 mg take 2/5 mg is equal to ma. So the acceleration is actually independent of the mass. And so you can actually divide through by the mass. And then 3/5 minus 2/5 is 1/5. And so A is equal to 1/5 G. If you want to round that, that goes to 1.96. If you want to be really fussy and do that to 2 sig fig, it's 2.0 meters per second squared to 2 sig fig. Right, next bit of that question is to find the distance it slides in the first 2 seconds. Didn't prepare this in advance. So the distance the particle slides in first 2 seconds. So if you have constant acceleration, you're looking at using your Suvat constant acceleration equations, which are in your formula book. They might be under AS mechanics, but they're all there, those 5 equations. Acceleration is constant, it's not dependent on time. And so just write down what you know. So it's being released from rest, so U is 0, T is 2, make sure you're in standard index units as well. And A is 1/5 G, which is 1.96, and we want to find the distance. So that's what we want. Find the relevant equation, so it'd be S equals UT plus 1/2 AT squared. And then just substitute in. So S is equal to UT, which would be 0, plus 1/2 times 1.96 times 2 squared. So it answers to 2 sig fig, so S is equal to 3.9 meters. So I'm just going to give you a few questions where there's just a little bit of Suvat in them as well, just to get you thinking about that.